Are you ready, kids? I can't hear you. What's happening, guys? Mr. Cochran here. As you can see, we are still in that statistics topic, 9, I believe it is, right? Scatter plots, correlations, and linear and exponential regressions. I think you're going to enjoy this lesson. One, because it's very visual, and two, it's very Desmos friendly. As you can see, we have our best friends up here, 1 and 2. So why waste time? Let's get at it. All right, so the first thing that we're looking at is scatter plots. So as you can see, these images that we're looking at are plots of data, right? So you have correlation as well was our other word. So the scatter plot is obviously going to be the data that's put on the graph, and then we're looking for correlations. When things are correlated, normally they kind of go together, okay? So that's kind of the definition of correlation. Kind of like, hey, the more you study, there's a correlation to your grade probably. The more you practice and do your homework, your grades kind of correlate to that time and effort put in, okay? The other thing we're going to focus on are these numbers down here, 1.9, 0.50. We're going to get to that here, the R value, in a second, all right? So the correlation coefficient, the measure of the strength of a line best fit. So what we're saying is we are trying to get information and put a line between as many points or kind of where those points lie, okay? So this is a really good, perfect negative correlation. Here, this is pretty close too. You can kind of see how that travels through those. Here, it's weak, but you can see how the data tends to go negative. So that line of best fit is weaker than these two over here because obviously these data points are much closer to that line of best fit is the other word that I didn't put on the opening slide. No correlation. You can't really tell what your data is doing here. You can see that that's a 0. Weak, positive. This information's trending upward now, but it's a little bit weaker because you have data points above and below. Strong, positive, and then the perfect positive is that straight linear line, right? 1 is perfect, 0 is no correlation, and then -1 is just a perfect negative correlation, or that information is trending down. So that's your negative. Over here, you're getting weak, strong, and then perfect positive correlation, okay? So again, this is the R value, which I believe is our next slide. The correlation coefficient, denoted as R, is the measure of how well a collection of data points can be modeled by a line. Correlation coefficients range between -1, that's the perfect negative correlation, and 1, the perfect positive correlation. The closer the correlation coefficient is to 1 or -1, the less scattered the points are, okay? So that's where it's going to be really close to that line of best fit, and the stronger a relationship. Only data points that the scatter plots, which are perfectly straight line, have a -1 and a 1R value, okay? So again, the correlation coefficient is going to be what we're going to call that R, all right? So the closer it is, the closer that scattered plot, that data, is closer to that line of best fit, and that's what we're going to use Desmos here shortly. All right, so the scatter plot shows relationship between hours worked and money earned. So if we just kind of talk about hours worked and the money earned, just think about that correlation. We should have what happening here? A strong positive, a weak positive, a strong negative, or a weak negative. If we're working lots of hours, we should know that we're going to get more money. And this set of data looks really, really close together as far as it doesn't go up too much, doesn't go low too much. You have a pretty good line of best fit right there. So I'm going to go with a strong positive correlation because those sets of data don't really get too high or low from that line of best fit. Here, the scatter plot shows relationship between the age of a car and its value. So here's your age of the car on the X. Here's your worth on the Y value. And you can see that this line of best fit you have a little bit more scattered above and below. So even though this is, 7, 8 years old, it's not worth as much, maybe because it has like lots of miles on it, or it's been in car accidents or something like that, right? But this, 11 years, is a pretty good amount of money still, because it probably has low miles or has one owner. Those are kind of like the big points of used car salesman will use on you. All right. So if we draw a line of best fit, we can see that it's trending negatively. However, we have points that are pretty high above it and pretty low below it. So I would say it's a weak negative correlation, right? I would say that's weak just because the distance, that residual values are kind of further away from that line of best fit. All right. Last but not least, the scatter plot shows between age and height, which best describes relationship in that variable. As you know, you can't make fun of my height unless you're taller than me. So although I am not that tall of a fella, I am a lot older than you guys, and some of you guys are obviously taller than me. Some are still shorter than me. However, age doesn't really matter. It's more obviously based off of genetics and stuff like that compared to your height. Obviously, your inches are going to change with, especially this early on, 0 to 4, 6, and the inches in height. However, for this set of data, you can't tell if it's trending up. You can't tell if it's trending downward. So I would go with no correlation for that one. All right. Match the correlation coefficient to the correct graphs. Write the letters in space. So with this, again, remember, negative correlation means it's obviously going down. The closer to -1, the stronger the correlation is. The value is closer to 1, the stronger the positive correlation is going to trend. So if I just look here, C looks pretty close to being a straight line. So I'm going to put C with 0.99 because that's really close to being a perfect correlation of 1. All right. If I look at A, that's trending upward too. If I look at B, that's kind of trending negative but pretty weakly. How do you want to attack this? Let's just start, I guess, with this negative 0.85. So that's a pretty strong negative correlation. So what one looks the strongest? B looks pretty negative. D looks pretty negative. So what looks stronger between B and D? I'm going to go with D for this one. So I crossed that one off the list. I crossed C because that one was pretty obvious with the 0.99. The other negative one right here is negative 0.4, so I'm going to go with B for that one, just so I don't accidentally put the same letter for one of those coefficients. 0 means no correlation, so I'm going to go with F for that one, right? I don't think F really has any positive and negative. It looks kind of all crazy over there. So we'll cross that one out. And now we have 0.33 with its weak positive, right? Correlation, and then 0.87, which is stronger. But obviously we already said this was the strongest one with C. That's why I went with the 0.99. So what one's stronger between A and E? I would go A is definitely stronger, so that's going to be closer to 1, which 8.7 is, and then E being a weaker positive correlation. All right? So I hope that makes sense. Obviously, we're paying attention to those values. Stronger is either closer to -1 or +1, depending on if we're talking negative, it's closer to -1, and then if it's positive, we're talking closer to 1. 0 is at no correlation. All right, so it can't be greater than 1, and it can't be less than -1 for that correlation coefficient. All right, linear regression. I love this image. I don't know why, so I copied and pasted it for this one. Y equals mx plus b, because what does that make? A linear line, right? And of course, we're going to use our bestie here, Desmos, okay? So if we look here, it says a biologist is studying a relationship between a tree's diameter and its height. She records the following data for 7 different trees. So the first thing we need to do is find the line of best fit. What's the slope? What's the y-intercept? What's the r-value? What does that mean? What is the predicted height of a tree of 5.5? Find the predicted diameter of a tree that's 25 feet tall. So obviously the 4 is talking, they're giving us the x value here, and they're giving us the y value here, so we need to find the x. Here we need to find the y, okay? And again, you can see I already said use Desmos. So what I did already, just to save time, I punched in this table of information, and I got this right here. Something cool is, if you notice right now what we have going on here is we have our window is -10 to +10, up to 6, down to 6 on the y. If you hit this setting, we can change our x-axis. So if we talk about our axis here, 2, 3, 4, 5, 6, 7, 8, I'm going to just change this to 0 just to give me a little bit of a better picture of this information. Here I go 8, 10, 16, 17, 22, 20, 29. So I'm going to change the y-axis. I'm going to do the lowest point to, what are we feeling here? 8. So let's go with 0, 2. So we're going to be in that first quadrant. We don't need negatives there. And then our highest point is 29. So let's go up to 35. So we can change our window so we can see this data right in front of us. So hopefully that helps us out a little bit, right? Does that make sense? So here's our data. And now we're doing a linear regression with that information. So check this out. You need to type this down. You need to write this out so you know exactly what to do. So before, in a calculator, there was this whole drinking lemonade, cold lemonade, something crazy like that. Miss Thomas remembers it better than I do. So ready? The first thing you're going to do for Desmos, it does everything for us. It's super simple. We're taking the y equals mx plus b formula, okay, and we're going to do a linear regression with it. So we're going to type in y1, because we're going to use this table of information right here. See how it says this 1, 2, 3, 4, 5, 6, 7 elements? Yep, we're going to use that list right there. You're going to hit shift and the button right next to the number 1, and you're going to get that twiddle, is what they call it in Desmos language. It's called a tilde in other language, I don't know, but they call it a twiddle. I thought that was kind of funny when I was watching Desmos videos. And then we're going to use the formula, what? Mx plus b. So we're going to use m as our slope, x1, because we're going to use the set of data there, and then plus b, because that's my line or line formula, y equals mx plus b. So now if you look here, they're giving us this information. Pretty cool, right? What is our m value? Our m value, they tell us, is 3.17857. So that's my slope. All right, my b value is my y-intercept. All right, and then if you look here, that r, remember we talked about that a couple slides before? That's my correlation coefficient. 95, man, that's pretty good, because it's, or 0.95, I should say, really. That's really close to 1. So this is going to be a strong correlation. You can see that right here in the red line. That's my line of best fit. Although it doesn't have to go through the point itself, it does go through this one. It misses this one. This is just a little bit below. This is just a little bit above. This is just right underneath it. So you can see how it splits the data set. That's what we call the line of best fit, okay? So again, our correlation coefficient is super, super close to 1. So this is a really, really strong correlation here. So this is pretty cool, though, because now I'm going to take this information and I'm going to use it to write y equals 3.2. I'm just going to round this information here. X plus 1.5. All right, so I'm just going to leave this as the expression here. So this is my line here. I'm just going to change the color because it was red before. Let's go here. Let's change it to orange for the browns, right? So there is that line. What you want to do with that now is because they're asking us questions. So the line of best fit, we said was what we just typed in the Desmos, which was 3.5 or 3.2x plus 1.5. So we can write that on our slide. Y equals 3.2x. And I already forgot our y-intercept, 1.5. What is the slope? The slope is 3.2. That's my change of y or my change of x's. What's my y-intercept? That's the 1.5. So that's my initial height. What was the R value? That R value is 0.95. I do remember that, and that means it's a very strong positive correlation, right? So now the cool thing about Desmos is now they're going to ask us to predict what 5.5 would be for the x value. So check this out. Now that I have my expression written here for my slope-intercept form, I'm going to hit table. I'm going to convert that information to a table, and they wanted 5.5. So I just type in 5.5, and it gives me this information, right? It tells me how high. I could also trace it, right? I could trace along this line too and say, hey, what's that 5.5? And obviously it's going to be right there at 19. All right. The other question was, so we're going to say this would have been at 5.5. That's the x value. My y value would be 19.1 feet, right? And I used the table from Desmos. That's a really cool feature of Desmos. And now predict when it's going to be 25 feet. So what I can do is just trace this line until that y value hits 25. Is it 25.5? What was it? Just 25. So we're going to trace until the y value is 25. So we are looking at, I can't really stop perfectly on it. Let's just go with 7.39. Sure. It's close enough to 25. All right. So this would be 7.39 for the diameter, right? Because they gave us a y, we found that using the graph. Cool? Does that make sense how we did that? If you need to, again, pause it, rewind it, and again, it's very, very awesome, the power of Desmos. That's why we call it your best friend. Exponential regression. So this is exponential functions. So if you don't remember that, don't worry. I got your back right here. It's y equals a times b. Remember, a is your y-intercept, b was your multiplier, right? And then your x was what you're going to be inputting. They gave us a table of information. Don't worry. I got your back. I already have that. I kind of changed my settings too. You can see how this is a curve. It looks like it's trending positively. So what do we have to do? We need to do that Y1 and do that shift, the button next to the left of 1, that twiddle. And now we're going to type in the exponential function, which again, I shared with us right here is a times b to the x power. So let's type it in, a times b. And then we're going to hit that AB button, raised to the X1, because we're going to use this information here, which is my X1 and my Y1s to help us. And if you look here, holy smokes, this is a super, it's almost perfect. That information, 9 or 0.9998. So we're what, 2/10,000ths off from being a perfect line of best fit. Well, I guess it's an exponential function. I don't know exactly what they're going to call that. But our A value is 3.0069 and our B value is 2.03. So we would just type that in as, I'm just going to round it to the nearest 10th. So this is 3. And then we would have our B value. I'm going to put in parentheses as 2.0. Round to the tenths. And then, of course, we're going to have that to the x power. So as you can see, it changed it just a little bit just because I rounded it, because this is blue now. And then all you have to do is click that. Hit the plus sign. I think you want to just hit table. Just kidding. You want to hit the gear. So when I hit this, when I type in my expression here, I'm going to hit the gear, and then I'm going to create a table. And then you could type in whatever value you want as your X, your input, right? And then let's say I wanted what 15 would be. It's going to get pretty big. Yep, real quick. 98,000. Let's say I wanted 7. 7's 384. How about 4? 48. So again, it's pretty awesome, the power of Desmos and how it can help us create tables and use our information that we type in and found using our data points and getting information from that. All right. And last but not least is the best slide, the last slide, because it means we're finished. So again, we talked scatter plots, we talked R value, the correlation, right, coefficient, linear and exponential regressions, okay? So other than that, if you need anything, you know what to do. Email us and ask questions during class, and we'll be happy to assist you. All right, check out the Delta Math, and like always, subscribe, thumbs up. Here we go, brownies. Here we go. Hoo, hoo.